Hello people, you're on the pick of the week. So that's a specific selection of wonderful problems and questions. Today I've picked up GCSE Maths. It's also suitable for A-level and IB standard level as the sort of assumed knowledge. So it was picked up from paper 2, but actually I decided to rearrange the questions so that it's going to be a bit different so that you can have an extra practice. Alright, so if you're ready for that, let's get started. Pause the video, try to do by round, and let's see my explanation. So the topic, as you noticed, is all about tangent to a circle. Basically, you need to be aware of properties for tangents, and also you need to be able to set up the right equation for the tangent line, define the gradients, x and y intercepts. It's all about that. Alright, so here's my explanation about this problem. First of all, you need to find the equation of the tangent line. So we have the tangent line. I'll mark as t, and we'll be working towards getting this equation for the tangent line. As you notice, this tangent line shares the common point 10, 8 with the circle. Obviously, you understand that in order to find the equation of tangent line, first of all, we need to set up the equation in gradient intercept form. And I would do in this way, mx and plus c was going to be y-intercept. But for simplicity, I'll use different letters. So let's say k is going to be y-intercept. So that means point A will have the coordinates 0 for x and k for y. And what about b? So b coordinates are going to be, I just move a little away. So b coordinates are going to be, let's mark with the letter p as x-intercept, and that means b coordinates will be p and 0 for y. Alright, hope you understand how it comes from. So that means the equation of the tangent line should look like m, the gradient of the tangent line, and mx plus k in this case, y-intercept. Alright, so we've got it as y-intercept, and this also y-coordinates for the point k that we need to establish. Alright, how to work? There is no single idea how to do that, except for we notice that according to the property of the radius, it's always perpendicular to the tangent line. So it means here we will arrange 90 degrees angle. Alright, so that means the gradient for the tangent line is going to be the reciprocal for the gradient of the line that coincides with the radius. So basically it contains the radius as the segment. So if we mark the gradient, as grad, so we can write as 1 over gradient for this line that goes through 0 and 10 and 8. Alright, how to work out this gradient? So gradient is simply by definition change in y over change in x. That means we've got, because it goes from 0, to simplify our consideration, that means change in y is simply 8 and over 10, which is 10 change in x. Alright, so if we put those values into the formula, we get basically a reciprocal fraction is going to be negative 10 over 8. So you can work it out and say, so no matter which way you go, using calculator or just do it manually. So I'll get negative 5 over 4 or simply negative 125. And indeed, the gradient should be negative for the tangent line because it's sloping down. Alright? So right now what we know that the equation should look like negative 125 times x and plus k. Alright, how to find k value from here? Because we need to finalize with finding k value. That will give us complete equation for the tangent. We just can plug point 10a because your line goes through, and that means you're eligible to plug the coordinates. Alright, so 8 goes here instead of y, and 10 goes here instead of x. So we'll get 8 equals negative 12.5 plus k. So that means k value is going to be 20.5. Alright, and that means point A should have the following coordinates 0 and 20.5. All right, so I write more proper 20.5. Okay, so we've got the equation for the line, and I'll use the black one. The complete equation for the line, for the tangent line, is going to be negative 1.25 x and plus 20.5. And by the way, we establish in B part that k value, that means coordinate for A, is going to be 0 and 20.5. How to find B coordinates? Let's go there, and we'll see that right now what we know. We know that this tangent line with well-known equation here, that's the tangent line, goes through the point B as well. So it means that x-intercept of this line is going to be P, all right? So here we definitely know that when x-intercept occurs, y is 0. So that means we can plug y equals 0. So for B, with coordinates P and 0, we can equate 0 for y, and instead of x, we can consider P values. So that means we'll get negative 125P and plus 20.5. Right now, we definitely know that P is simply the fraction 20.5 over, so 20.5 over 1.25. And that's going to be the fraction which delivers the value 16.4. Okay, so it looks fair. And right now we can finalize with the B coordinates as our final answer. P value is 16.4 and 0 for y. So hope you liked it. It was pretty easy, as it was 5 minutes maths, GCSE level, and if you're a starter of A level or IB, that's also should work for you. Hope you like that. Don't forget to subscribe if you're new here. Smash those fat thumbs like button, thumb up, and stay with us. See you next time.